All right. So this kind of stuff up here is bread and butter stuff. I mean, this is, unfortunately, people nowadays, for some reason, earlier in math education in like high school and before that, are not doing percentages very well or something. I don't know. So that's not your fault, but now it will be if you don't get better at it, because now you know you need to. What does percent mean? What does that symbol mean? The percent symbol, what's it mean? Per cent. Yeah, per 100. So I want you to realize this. The percent number will always be bigger. See, 42.7? It will always be bigger than the decimal number, because the decimal is what you get after you do the division. Let that make sense. So you can always kind of stop and double check. So for this one, since I'm talking about it, if I divide by 100, like it tells me to, what happens to the decimal place?
It moves so over 2 places.
Yeah, back twice.
So
Yeah. And here's another way to look at it. Decimal percentage. See how I put them in alphabetical order?
Yes.
So if I want to go from a decimal to a percent, I move the decimal that way. If I want to go from a percent to a decimal, I move the decimal that way. Isn't that silly? But I'd much rather you do it because it makes you understand the idea, but you always got this kind of thing to think about. So how do I take that into a fraction? All right, now watch. Help me out. What place is this? The 1. What place is that in? Don't make me say. Not the first day. What place is the 1 in? Thousands, right? What place is the 2 in? What'd you do to 1,000 to figure out what the next place was divided by 10? That's in the hundreds place. So if that's the hundreds place, that's got to be the 100 divided by 10 is tenths place, right? Tens place. 10 divided by 10 is 1. That's the ones place. 1 divided by 10 is 1/10. 1/100th. 1,000th. Yes? Why is our number system based on 10? I wish I knew why our number system. It's because we have 10 flipping fingers. So, of course, the early way of counting would have based everything off of 10. There's one set of hands, and then there's 2 sets of hands. And now we call that 20, right? You guys with me? So if we would have had 8 fingers, don't lose our thumb, because then we don't evolve. If we would have had 8 fingers, we would have had a place 8 system, and that's all I'll say. I don't want to freak you the shit out. It would have been a little bit different. Okay. So, what place is this in? Tenths, hundredths, thousandths. So 427. And here's another cool, sorry, you guys couldn't even see that. Here's another cool way to do this. How many decimal places are there?
3.
So there's 3 zeros. Because every place corresponds to another multiple of 10. So that's why that's a beautiful shortcut. Oh, cool. Okay. All right. So let's go back up to the first dude. Why is this relatively easy to make into a decimal? I don't actually have to do the long division. Why? What can I make this over? Anybody do it this way? No? Yeah, I could make it over 100. Sure. I might as well do that. So if I make this over 100, what'd you do to 5? You multiplied by 20. So 3 times 20 is 60. So here's 60 hundredths, right? And then 60 hundredths is what percent? 60. By definition is 60%. Kick ass. Yes, ma'am.
So since I'm just used to doing the decimal and the number. Do you want the 0? 0.60?
I don't always. I normally do. The only reason we kind of put that 0 there is so the decimal place doesn't get lost.
Okay.
But if you don't put it there, it doesn't mean that it's wrong.
Okay.
So if you don't put a 0 in front, you're not going to get it wrong. The reason people do it is so that the decimal place doesn't just kind of get lost. Poor little dude, right? All right, how are we doing so far? So this next one won't be too bad. Fractionally, what would it be?
64 over 1,000.
64 over 1,000. And then what's the percent going to be?
6.4.
6.4, good. Once, twice. Everything's twice because it's 100, 2 zeros. It's going to move the decimal place twice. I like it. I like it a lot. All right, so what about this guy? What's he going to be as a decimal?
You add more decimals. Point.
You're going to move it back twice. Once, twice. You're going to have
3 zeros.
3 zeros. Kick ass. Now watch this real quick. What did percent mean again?
Per 100.
So if I write this as the answer to my fraction, why is that wrong? Isn't 0.03% 0.03 over 100? Isn't that right?
Yeah.
But it's not a fraction, because a fraction is defined to be the ratio of two whole numbers. Now real quick, go with me. This is not right. Freaking 0.03. Well, don't I have to move the top twice to make it a whole number?
Yeah.
So then I just move the bottom the same number of places.
So it's 3.
So it'll be 3 over
10,000.
10,000, which is what you get from here, right?
Mm-hmm.
Tenths, hundredths, thousandths, 10,000ths. Sounds like I got a lift. 3, either way you do it, you get 3 over 10,000. All right, this last dude. This next dude is a little bit freaky, but isn't it a mixed number? This is by definition a mixed number.
Yeah.
So you can either look at it like that. Well, first off, what is it as a percentage?
112.
Yes, once, twice, 112%, which would not make sense for an answer to a probability question, right? Well, it's probably going to rain today. 112. What the? 112? Giant raindrop. No, I don't. Right? So when we get to probability and you get an answer bigger than 100%, you don't write that shit down, right? You go, I did something wrong. So chances are going to get out of this year 150%. Well, what does that mean? 112% does make sense, like profit. Our profit was up 112%. Of course, because it could double, it could triple. But when you're talking about probability, hell no, this don't make any sense. Okay, maybe. Now, how do I get to a fraction? I got a couple different ways. What's 112%? 112 over 100, or 1 and 12 hundredths. Either way. So you could either say it's 112 over 100, or you could say it's 1 and 12 hundredths. And why are these the same? How do you make that into an improper fraction? 100 times 1 plus 12. Bam. Right? Of course those are the same. Okay. What about this dude? What do you got to do with this guy?
I divided 3 by 16.
Yeah. Just don't do. Now watch. This happens so much. So if you did this, just don't do it anymore. People will write 3, 16, and then they'll do this. They'll say 3 into 16.
No, it's 16.
Holy shit. And that happens so much nowadays. It makes me really, really concerned. Because this is 16 divided by 3. And I think it's because your brain says, 16 don't fit in 3? They must have meant. No, so of course that's the whole idea. The answer is supposed to come out much smaller than 1, right?
Yeah.
So if you do 16 into 3, add some decimal places, you'll eventually get there. All right, and if you don't remember how to long divide, here's another way to do it. You all should know what 3/4 is.
Yeah.
What's 3/4?
0.75.
0.75, right? 3/4 is 75 cents. 0.75. 3/16 is 1/4 of that. What's 1/4 of 3/4? I'm not saying you have to do it this way. Just saying this is another way to do it. What's 1/4? What's of mean? Here's another thing from high school that doesn't happen anymore. What's of mean? Times.
Oh, it's that simple.
Isn't that 3/16?
Yeah.
And here's an even better way. And I know I've lost some of you guys, but again, this is just another way to do this. 1/4 is 1/2 of 1/2.
Yeah.
So if I take 75, cut it in half, I'll get 37.5. Cut it in half again, I'll get 18.75. So you got 0.1875?
Yeah, that's right.
Yeah. Am I saying you have to do that? No. And some of you guys are like, I have this thing, it's called a calculator, that you didn't let me use, Jeff. I don't give a shit. We're the humans. We made these things. We really should be able to do some of the basic shit this thing can do, right? I just want you to guys realize what other options there are to do things like this in your head. But you don't have to. So this should be 0.1875. Whatever way you do it. You can just do it this way again, right? You'll still get the same answer, 0.1875. Let's get one more zero. And then, of course, what's that as a percent?
18.75.
Kick ass. All right, sweet. And here's, well, all right. I'm going to go off on a few tangents throughout the semester. And right now, I just want to show you one other thing that you should be kind of pissed about if you don't know this. Let me see, where should I put this? It doesn't matter, Jeff. Can anybody tell me, for example, most of you guys should hopefully know this. How do you know that this number is divisible by 9? Anybody know? Just looking at it. Don't do it and see. How do you know that's divisible by 9? Does anybody know? What's 1 plus 0 plus 8? What's 1 plus 0 plus 8? So it's divisible by 9. Does nobody actually know that? And it's not your fault. If nobody ever tells you something, how could you know it?
Yeah, I didn't know that.
But you should be a little pissed right now that nobody ever told you that. What's 9 times 5?
45.
And what's 4 plus 5?
4 plus 5 is 9.
Yeah, right? Right? Yes? No?
Yeah.
Yes?
Yeah.
No?
Yeah.
Yes? Okay. So, for example, is this one divisible by, what you got, Jeff? By 9. What's 1 plus 6?
18. Yes, it is divisible.
Yes, 7 plus 7, 14 plus 4 is 18. If you come up with something that's divisible by 9, the whole thing is divisible by 9. Isn't that a useful thing? I know calculators exist, but I still would, that's relatively simple.
Yeah.
And it seems like most of you didn't know it. Do you think you maybe forgot it, or you think you were never told it?
I never was taught it.
All right. So what about this? Here's another one. That's division by 9. What about division by 3 is the same way.
So
If you add them up and they come out to be a multiple of 3, then 3 goes into it.
is that
Even, you guys know. What?
is that
Yes.
for every single number too? So like
No, careful. Oh, shit.
Okay.
So 3 and 9 have similar rules because they're based off each other in a way, right?
Mhm.
How do you know if 2 goes into something? Well, if it's a... How do you know if 2 goes into something if it's
Oh, yeah.
even? So everybody knows that rule, right? You almost can't escape that rule. How do you know if 4 goes into something? So watch this. You ready? Somebody give me a number. Give me a single digit.
So
What? 5? Give me another one. 2? Give me another one. 6? Give me another one.
8.
8. And then if I put 48 at the end, that is divisible by 4.
Is it 40?
Because the last 2 are
40.
divisible by 4. As long as the last 2 digits are divisible by 4, the whole thing is. Why? Because 4 goes into 100. Because 4 quarters is 100, right?
Yeah.
Therefore, 4 goes into 104. 4 goes into 112. Yes?
Yes.
4 goes into 200. So 4 goes into 208. So it doesn't matter what the first pieces are. All that matters is what the last 2 are. You guys with me a little bit?
Yeah.
Okay. 5, you know. If you don't know 5, just leave, right? 6. What about 6? 6 is interesting.
Oh, okay.
What is 6 made of? 2 and 3.
2 and 3.
So it's got to follow both the rules. So it's got to be a number that adds up to be a multiple of 3, and that number is even. So, for example, what do you got? This number is divisible by 6. Because it adds up to a multiple of 3, and it's even, which means 3 goes in, and 2 goes in, which means 6 goes in. No, yes, maybe. 7, poor little 7 doesn't have a rule.
Yes.
We don't know shit about 7.
Well,
8, the last 3 have to be divisible by 8. So that's a hard one to apply, right? But that one, for example, this whole thing is divisible by 8 because the last 3 are divisible by 8. See how it's very similar to 4's rule? Which makes sense. All right, I'll stop. All right, that's a lot. Yes? No? Isn't that cool?
Yeah.
So isn't that stupid when a lot of the stuff is, well, we got calculators, well, you have to know shit. Well, because they want to know shit. You guys want to know this stuff. And, anyway, sorry. All right. It's just sad to me. Every time I do that, less and less people know about these things. All right. Jeff, let it go. Let's see, what about this one? In a class of 40 people, there are 5 left-handed people. What % are left-handed in the class? How do you figure that out?
5/40.
Yes.
100.
5 over 40, which reduces to,
12%.
reduces to
0.1.
1/8.
1/8.
Now you could do 40 into 5,
And
long
that's
division.
0.125.
Yes, that's 0.125.
And
Because again, 1/8 is 1/2 of 1/4. What's 1/2 of 25? 12 and a half. So 0.125, which you can then write as a percent. 12.5%. Bam. So these are 2 examples of the little bit of algebra you actually have to be able to do. Both of them are similar in the fact that, what's the worst part about those equations? Both equations have what in them?
variables.
Oh, okay. Well, equations normally do.
It's not the worst part, but.
What's the worst part? Getting past the fact that it's got to have variables in it. They both have fractions, right?
Oh, okay.
Don't we all kind of hate fractions?
I don't.
And I'm really good at math. I don't hate them, but I will get rid of them if I can. Because I'm a human and we make mistakes with fractions and negatives and shit, right? I don't care how good at math you are. So the very first thing you want to do with this equation is get rid of the fraction. Why am I allowed to? Because I have 2 sides that I can do anything I want to except multiply by 0. That's almost or divide by 0. I can't do that to both sides of an equation. I can do almost everything else. So what do I want to do to get rid of this? What is this letter, by the way?
That's sigma.
Sigma. How do I cancel it out on this side?
Multiply both sides by 6.
Good. And whatever I do to one side, do the other side. So I get die. Bless you. I get z sigma equals x minus mu. My sigmas are, sometimes they're skinny and sometimes they're fat. I don't know. Just depends. And then what's the last step to get x by itself?
You add both sides. You add the whatever that equation is.
Yeah, this is a French cow. Mu.
Mu.
That's just for me. It's all right. You don't have to laugh. It's okay. Bam. So x equals mu. That's going to be a huge formula for us, both of these. The beginning formula and the formula we just got. We're going to use those quite a bit eventually. This guy, not as much, but still, he's going to be important. The extra thing that sucks about this one is where's the n? Not only at the bottom, but it's also
Inside a radical.
inside a radical.
We just cancel that.
Yeah, so I do the same thing I did on the last one. I multiply by rad n. And I get rad n times e equals z sigma, because these die.
And then divide by e.
Yeah. Right? So I almost got the n piece by itself. I just got to get rid of the e. And of course, how do I kill a square root?
Square it.
Square both sides.
So then
Hopefully you can sort of read that. Okay, a little bit. You're not gonna, no, not at all. I'm sorry. I don't blame you. You're not gonna have to be able to do this by yourself a lot, but it will come up every now and again, and we will do it a lot together when we're working with the formulas. Okay. Hopefully that at least sounds familiar. If you sort of forgot how that works, how are we all doing? You wanted me to do that one more time? You guys, we do it on a clean piece of paper. So the first thing I do is multiply everything by square root of n, just to get it out of the bottom. And then I divide by e, because I want my n piece by itself. And then how do I kill a square root? I square it. How's that? And by the way, I forgot to tell you, I mean, you could You got a whole clean side on this. Hopefully some of you guys are using that for notes. All right. And I put this on here because we should really know how to find the average. All right, how do I find the average of any numbers?
Add them together and divide it by the amount
Yeah.
of numbers.
So add them all up.
And there's 5 numbers.
Sure.
So divide by 5.
Yes. So when you add these all up, you get 39, right?
Mm-hmm.
Now here's a cool trick. You can just do 5 into 39, that's fine. But whenever I divide by 5, if I double the top and bottom, I'll have a division by 10. And division by 10 just moves the decimal back once. So if I double this, I get 78 divided by 10, which is 7.8.
7.8.
Bam. So divide by 5 is double, move the decimal back once. Bam. Now please, dear God, if I had done this work and I got my answer was 17, why can't I immediately tell it's wrong? If I get an average of 17 for this data.
Because it's higher than anything you have
Yes,
in
the
there.
average has to be where? It has to be in the middle. The average is one way to get a feel for where the middle of the data is. Okay.
So you said anytime. Wait.
Divide by 5?
Yeah, you're dividing by 5.
You could double the top and then move the decimal back once, because you're effectively making it a division by 10 then. Same thing works with 50. If you double it and then move it back twice. And do you really have to be able to do any of what I'm saying? No, because you got calculators. I know you do. But still, some of your brain should be like, yeah, I want to be able to do this shit on my own. Here, while I'm thinking about it, here's something else you might like to know. If I had to do 1 minus 0.9273, right? In fact, let me start here. What's 20 minus 7? 13. What's 19 minus 6? Isn't that kind of still? Of course, it's the same math. They're both 13 because if I move 20 down 1 and 7 down 1, they're still 13 apart, right?
Yeah.
So if I do 1 minus 0.9273, I could make that 0.9999 minus 0.9272. All right, now stay with me. Stay with me. There's a really cool shortcut coming up. So if I had to do this, and I had to do it longhand, do you see all the borrowing you have to do? Shit, I can do 0.9999 minus 0.9272, the same idea I just used over there. Now the ultimate, don't even do that shit. You ready?
Mm-hmm.
So using this more directly, if I make all of them 9 except the last one, watch, what makes 9, 9? 0. What makes 2, 9? 7. What makes 7, 9?
2.
2. What makes the last one 10?
7.
Done. And you can double check. I mean, it's really using this idea very directly. So how do I do 1 minus any decimal? I make everything 9 except the last one 10, because that would carry through, make everything else 0, 0, 0, 1. Okay, I don't know if you guys are with me. And again, you're going to be able to use your calculator all the damn time, but we're going to be doing that kind of thing a lot. And it's actually quicker to do that in your head than it would take to get in the calculator. Yes?
So you turn everything to 9 except for the last
Yes.
one, it's 10.
So if I did 1 minus 0.4528, that would be 0.5, 4,
7,
7,
2.
2. Done.
Okay.
That's nifty, right?
Mm-hmm.
Could you live life and not know that? Of course, you've already been doing that. But knowing it isn't things a little better. You could do something more by yourself and quicker than the freaking calculator. Shit. Okay, sorry. Now, the last one is one of my favorites. If your grades were 81 and 72, what do you need to make an 80 average?
87.
All right. So what methods did you guys use to figure that one out?
I did 81 plus 72 plus x.
Kick it! Look at that shit. Algebra. There's a place for it. Algebra actually does something for us. What's algebra do for us? It's a method of, I don't know a piece, and if I knew it, I knew what to do. Well, let's just pretend like we know it. That's why I love algebra so much. I know the third grade. I know exactly what the third grade is. It's x. So if I add them up and divide by 3, I'm supposed to get 80. Now this next step in this is really interesting. If I have any three numbers that average to be 80, what do they have to add up to be? 240. Because that's the only thing you divide by 3 to get 80. So you don't know anything. If I said I have three numbers and the average to be 10, you have no idea what the numbers are, but you know they add up to be 30. I'm going to use that in a minute to show you a shortcut on this. So then I get, multiply by 3, 240, 81 and 72 is? And then I just subtract 153, and I get 87, right?
87.
All right, now watch. Everybody get that? There's a beautiful use of algebra. It's an excellent, strong problem-solving tool, but it's not the only tool that we have. So watch this. This is kind of neat. So the two I know are 81 and 72, and then I have an unknown, right?
Mm-hmm.
And I want them to average to be 80. Well, how far off from 80 is this? Up 1. How far off from 80 is this?
8.
Down 8.
Down
So
8.
overall, I'm down. Overall, I'm
You're
down how much?
Negative
7. So the last one better be up 7. Oh!
So cool.
So I'm really just using the idea that they have to add to be 240, so then I can see how much everybody is off from 80, and then make sure the last guy makes up for that. Yes, no, maybe?
Mm-hmm.
No, not at all. And again, you never have to do what I just did. You don't. Hopefully this makes sense, because you guys should have taken some algebra. Right? Okay. All right.
Excuse me.
Yes.
Can I take a look at the tree one again?
Which one?
The first one.
Yeah,
For the
the
notes.
3.
The third question.
Here?
Yeah, the first one. Yeah. Thank
This
you.
one? Okay. All right. Everybody else all right? Okay. So now if you want to, you can reorganize yourselves. You can go back to where you were. You can stay where you are. It's kind of neat how we all sort of came to the middle. That's neat. We're going to do some actual stats today before I let you out of here.
Oh, yeah. Well,
All right. I lost people. Oh. That's really, some of my colleagues are like, be an asshole on the first day, say, if less to great, people leave. No, that's terrible. I just lost. All right. Everybody got what they want from this thing? Everybody good? Okay. I'll be all right. I'll get over it. So I think I warned you in an email and on that concept outline sheet that the first, that's too far away. The first chapter is all definitions. So we're going to go through it a little bit quickly. So I like to do this with an actual specific example. Is there something about Grossmont students you would like to know, like the average height of the Grossmont student, or the percentage of Grossmont students that like jazz, or something? Anybody curious in any way about your fellow students? Or no, you're like, I don't want to know anything about them, just don't take my spot. You get here at 7, so you guys have plenty of spots to choose. That's nice. That's the one nice thing about such an early class. Anything you guys are curious about at all? The percentage in the smoke, the percent that are going to vote for Trump, the whatever, right? What do you guys, anybody? You don't want to know anything. I love you guys. You're like, we're not going to give you any math today. Come up with something yourself. No. All right, so what about if we're curious about the percentage of Grossmont students who who play the flute? Why? Right? Sure. You guys with me? Nobody gave me anything, so that's what we're going to work with. Can somebody turn that light back up? Thank you. So, there are a couple terms you already know coming in here. You definitely know the word population. Right? Normally it's discussed in terms of the earth can only hold so many, holy crap, right? Population explosion. So what's a population in statistics specifically? What would be the population up here?
Group of students who play the flute. Grossmont students. Grossmont students.
Yes, all Grossmont students. The population is the group that you want to say something about. It's the entire collection of things or people. Right? So the population in general is the entire collection of people or things we wish to describe or discuss. Okay? Is that the Webster's dictionary? No, I don't know. That's a definition of population. So in this case, the population is definitely all Grossmont students. Now watch, real quick. I want to make sure you guys understand this, because people get upset when you lose points for this. If I said there are bikers next door, in the room next door, right? Can you envision that? Some bikers, right? And I didn't say some, I just said there are bikers. What if I said all bikers are in the room next door? Could they possibly fit? This room would have to be insane, right? It'd have to be the TARDIS. Yay, bigger one needs. That ain't gonna happen. So, but do you see how if you say the population was Grossmont students, I'm gonna take points off. Which Grossmont students? So when you answer a population question, make sure you're referring to the entire collection, and normally that's just all, right? All, whatever. Because if you don't use the word all, it actually could mean less than all. And it's got to be all of them. What's the word sample mean?
Students who play the flute.
No, not specifically. And there's an issue with that, but we'll get to it. Just what's a sample?
Like a piece or a cookie.
Yes,
like a
so
little
it's a subgroup
subgroup.